Good afternoon, students, faculty, friends, and all our honored guests. My name is Sonia Velasquez, and I am Associate Professor in the Department of Comparative Literature and Religious Studies here at Indiana University, Bloomington. I have the pleasure and honor of being president of the Gamma of Indiana chapter of Phi Beta Kappa, and I am myself a proud member of PBK, excited to welcome you here this afternoon into this historic and purpose-driven society. Today, we will formally induct our newly elected members as we celebrate their welcome to the oldest and most distinguished academic honor society in America. Today's ceremony is a memorable occasion for our new members, but it is also an immensely important occasion for their family and friends. None of us would find any success without our communities of loved ones, and I want to extend a special welcome to our inductees' family and friends who are joining us via the live stream. The history of this society is a deep one, and to set the scene, we have asked Provost Professor of Spanish and Portuguese, Debbie Kohn, to begin this event by telling us about Phi Beta Kappa, its history, and the symbolic significance of the Phi Beta Kappa key.
Thank you, Professor Velasquez, and hello and welcome to everyone. So I'm here to tell you about the history of Phi Beta Kappa, the oldest academic honor society in America. The first chapter was founded in 1776 at the College of William and Mary in Williamsburg, Virginia. The students who founded it met at a local tavern, the Raleigh Tavern, to create a serious-minded student society that would offer more than social opportunities. Over the next half-century, Phi Beta Kappa chapters were established at other colleges and universities, including Yale and Harvard. While the original organization had been a secret society, most new chapters followed Harvard's example and replaced the injunction of secrecy. In 1883, the various chapters joined to form a national association known as the United Chapters of Phi Beta Kappa. Over the years, Phi Beta Kappa has been home to a broad range of notable individuals who have distinguished themselves in many fields. You'll see just a few of them pictured here. Phi Beta Kappa inductees include the formerly enslaved George Washington Henderson, who was the first African-American inducted into Phi Beta Kappa in 1877. There's author Mark Twain, author and activist Helen Keller, writer and singer Paul Robeson, sociologist and founder of the NAACP, W.E.B. Du Bois, physician and virologist Jonas Salk, environmentalist Rachel Carson, chemist Roger Chen. There's also novelist Viet Thanh Nguyen, American diplomat and political scientist Condoleezza Rice, former U.S. Representative Elijah Cummings, and 6 of the 9 current Supreme Court justices, including Justice Sonia Sotomayor and Chief Justice John Roberts. There are many, many more, including, more recently, poet Amanda Gorman. As for the Indiana chapter, it was formally established in 1911 on January 20th. That was, of course, the perfect day to do so, since it is the university's birthday, known as Founders Day. Our chapter is known as Gamma of Indiana after the 3rd letter of the Greek alphabet because it was the 3rd chapter established in the state after chapters at DePauw, Alpha, and Wabash Beta. You might have noticed that as a Phi Beta Kappa member, you are authorized to obtain a key. Now let me explain the significance of the various inscriptions on that key, whose design is drawn from the metal of the original chapter at William and Mary College. The core principles of a liberal education are symbolized in the Greek letters Phi, Beta, and Kappa. Those are initials of the motto, Philosophiae Biu Kubernetes, which can be translated as love of wisdom is the guide of life. In the upper left corner of the key, 3 stars symbolize the main aims of the society: friendship, morality, and literature. A pointing hand in the lower corner symbolizes aspiration to those aims. On the reverse side, you'll see the letters SP, which represent the Latin phrase Societas Philosophiae, meaning philosophical society. You'll also find the date of Phi Beta Kappa's founding, along with the member's name, the electing institution, and the year of induction. One of the best summaries of the principles of Phi Beta Kappa comes from John Hope Franklin, a distinguished historian who was awarded in 1995 the Presidential Medal of Freedom, not only for his lifelong work as a student of history, but for his determination to bring about a better understanding of race relations in modern times. He said the following: "The love of learning is one of the most powerful values we can teach the generations to come. It has been a backbone of American pride and achievement, and essential to freedom of thought and individual liberty. It is the envy of other societies that seek the kind of freedom of inquiry we have. Lose that, and we lose something very principled and very American." Well said, indeed. One final historical note. As I mentioned earlier, Phi Beta Kappa was founded in 1776. For 250 years, the society has honored the nation's most accomplished students and affirmed the enduring value of an arts and sciences education, one rooted in the pursuit of wisdom, curiosity, inquiry, and intellectual rigor. It is a true pleasure to welcome you into Phi Beta Kappa in this milestone year. Now that you know something about the history of this distinguished scholarly society, I'd like to recall Professor Velasquez to the podium.
Thank you, Professor Kohn, for that introduction to the history of Phi Beta Kappa. This induction ceremony is hosted by the College of Arts and Sciences, and I would like to call to the podium our host, College Executive Dean Rick Van Kooten. And the Gamma of Indiana chapter of PBK would like to thank Dean Van Kooten for his generosity in continuing the college's tradition of financial and administrative support of the chapter as we honor academic excellence.
Thank you, Professor Velasquez. So good afternoon, everybody. Actually, I realized I didn't even introduce myself when I came up here. I was in so much of a rush. I'm Rick Van Kooten, the Executive Dean of the College of Arts and Sciences. And it is again, my pleasure to welcome our newest Phi Beta Kappa electees, our guests in the room and the family of friends who have joined us online for this celebration. We're fortunate to have many of the deans with us today. I asked them to stand as I introduce them. Please hold your applause until all of them are standing. So we're joined by Peg Feynman, Dean of the Eskenazi School of Art, Architecture, and Design. Charles Lin, Executive Associate Dean of the Hamilton Luger School of Global International Studies, over here. David Toczynski, Dean of the Media School. And then our Associate Deans in the College of Executive Dean's Office. John Hansen, Executive Associate Dean. Elizabeth Cullen Dunn, Associate Dean for Graduate Education, and Vivian Halloran, Associate Dean of Arts and Humanities. There, over there. Thank you. Please be seated. Please also join me in welcoming the Executive Committee of our Gamma of Indiana chapter. I asked them to stand as I introduce them. Again, please hold your applause until all are standing. First, our president, Sonia Velasquez, Associate Professor in the Department of Comparative Literature and Department of Religious Studies. Terry Greenslade, our Secretary Treasurer, Assistant Dean for Undergraduate Education. Deborah Cohn, Provost Professor in the Department of Spanish and Portuguese. Greg Demas, Professor in the Department of Biology. Greg here, I haven't seen him. Jason McGraw, Associate Professor in the Department of History. And Sarah Osterhout, Associate Professor in the Department of Anthropology, right here. And finally, John Salzer, who's going to be our keynote speaker today, Provost Professor Emeritus in the Department of Astronomy. So a big round of applause for them. Also, please welcome our faculty members and academic advisors, some of whom were elected to Phi Beta Kappa themselves at colleges and universities throughout the United States. They're here today because they have served as mentors to the students being inducted into the Phi Beta Kappa, and they understand the significance of this achievement. Faculty and academic advisors, please stand so we may acknowledge you as well. So faculty and academic advisors. Thank you. Please be seated. I'm also enormously pleased to be here today to congratulate today's inductees on your election to the Gamma of Indiana Chapter Phi Beta Kappa. On behalf of the entire College of Arts and Sciences, let me tell you just how proud we are of you. This event really is one of the highlights of the academic year, when we gather to celebrate this cohort of outstanding students and to recognize the accomplishments of your undergrad years. You're at the very heart and the future of the College of Arts and Sciences at Indiana University. You've been elected to an organization that has existed since 1776, as Professor Cohen was saying. The year of the Declaration of Independence was signed, and its 250th anniversary this year. Phi Beta Kappa supports and amplifies the lives of students of high achievement and promise in the liberal arts and sciences. Only 10% of U.S. colleges and universities have Phi Beta Kappa chapters. And of that 10%, these chapters select only 10% of their arts and sciences graduates to join them. So it's a very prestigious recognition. As Professor Cohen emphasized, you're an excellent company. And in just a moment, we'll hear the Phi Beta Kappa keynote address, followed by a formal induction of our new members. After the induction ceremony, I encourage you to have your picture taken in front of the banner representing your major. So the banners you see lined up in the room just really gives you an idea of really the breadth and intellectual range of the College of Arts and Sciences, something that we're really proud of, something that we believe is at the heart of a university. You come from many different disciplines and divisions in the arts and humanities, social, historical, natural sciences, excelling in courses across the entire IU curriculum. You're well prepared to go from here to graduate to professional school or directly to enter a workplace where you'll help find solutions to current and future challenges out in the world. As students of liberal arts and sciences, you have cultivated a strong interdisciplinary core. You have strengths of habit and mind that will enable you to work collaboratively with people from a wide variety of backgrounds. You have skills as critical thinkers. Even more important in the age of AI is everything you've learned through these past 4 years. You're vital communicators and subject matter experts. You've also developed the practical skills that will further refine you as you navigate the challenges of swiftly morphing workplace and the world in general. You'll pursue your goals in a future that involves adapting to multiple opportunities, challenges, and careers. You'll be fortified by a mindset that is focused on growth and continuous learning. It's the motto of the Phi Beta Kappa. We're so proud of you and to have been involved in your education. We wish you every success and look forward with keen expectation to learning about your future achievements. And now I'd like to introduce our speaker, John Salzer, Provost Professor Emeritus in the Department of Astronomy, whose multifaceted career underscores the values and the value of Phi Beta Kappa. Professor Salzer earned his undergrad degree from Coe College in Cedar Rapids, Iowa, where he was elected to membership in Phi Beta Kappa himself. He went on to earn a MS in physics from Iowa State University and his PhD in astronomy from the University of Michigan. Prior to starting his faculty career, he worked as a research scientist at the Arecibo, Radio Astronomy Observatory in Puerto Rico and the Kitt Peak National Observatory in Arizona. Professor Salzer has broad research interests in the area of extragalactic astronomy. His current research focuses on measuring chemical abundances in galaxies and studying star formation in the nearby universe and beyond. His abundance research involves using spectra to measure the relative fraction of the various elements in hundreds of galaxies to understand the demographics of chemical enrichment, as well as measure the evolution of abundances over roughly half the age of the universe. His star formation studies focus on measuring the rate at which stars are being born in hundreds of nearby gas-rich galaxies, allowing him and his colleagues to carry out an unbiased census of star formation in the local universe. His current major survey project is called SFACT, for star formations across cosmic time. It uses novel observing techniques to detect and study star-forming galaxies out to distances where their light takes 7 to 8 billion years to come to our eyes. So that is well before the Earth existed. So think of twice the age of the Earth. That's when the light first left that galaxy to come into the devices that he just registers for determining what those galaxies are made out of. During his career, John has served on numerous committees and advisory panels, both at the university and national level, including serving as president at IU's Phi Beta Kappa chapter, Gamma of Indiana. Professor Salzer was bestowed with the Presidential Faculty Fellow Award by U.S. President William J. Clinton in 1995. And finally, my connection with John, I'm a physicist, so actually, in Swain, we're on the lower floors, and astronomy is appropriately on the top floor. And actually, one great event that we often go to together is we have viewing parties for donors and alumni up on Kitt Peak. First, it's a beautiful drive to get up to the top of Kitt Peak, and there's actually a telescope there that's being optimized by NASA with a special device to detect exoplanets, like the wobble of stars when exoplanets go around them. And actually, this is one of the biggest telescopes that you can unbolt the instrument and just slide in an eyepiece. And then the technicians, you go up there about 11 o'clock at night when it gets really, really dark, and then you just yell things out to the technicians below, and they skew the telescope to watch them. And it's actually really interesting because the images you see on a computer screen, for example, are actually better images. But nothing beats actually putting your eye up to it and knowing that this photon came, 4 billion light years away and went through my eye and hit the back of my eye. It's actually it's an incredible experience. In fact, there's bigger telescopes on the top of Kitt Peak. All the other astronomers come for these viewing parties because they don't experience that much at all of going a great big scope like that and getting the photons in their eyes. I'm a real nerd, so that's fine. But the title of John's talk today is Carpe Noctem. So welcome John Saltz to the stage.
We turned the lights down because, as I like to tell people, I earn my living in the dark. So we want to give you guys the full astronomy experience. So thank you, Dean Van Kooten. Let me begin by extending my heartiest congratulations to the new initiates. Membership in Phi Beta Kappa is a sign of sustained academic excellence that is broadly recognized, both within the world of higher education and beyond. So you should all feel proud of your accomplishments. The title of my address, Carpe Noctem, is meant to be a bit of a play on words. It derives from the famous Latin phrase carpe diem, which translates to seize the day, or more appropriately, make the most of today. As an astronomer, I have always felt a minor slight by this expression, so I decided to change it to carpe noctem. Of course, the well-rounded person should endeavor to do both, make the most of the day and the nights. Carpe diem et noctem. As you can tell, I'm fluent in Latin, most of which I picked up watching old Monty Python movies. So I'd like to focus my talk today on two themes. First, I want to stress the sheer beauty of the universe that we live in hopes of motivating why I was so inspired to study it. And second, I'd like to leave you with some modest sense of the research I do. My hope is to try to provide a glimpse of how an astronomer goes about studying the universe with the goal of making it seem accessible and understandable. So we begin our journey with an image of the night sky seen from a mountaintop observatory. In fact, the same mountaintop that Rick was just mentioning, Kitt Peak. The image shows the Milky Way galaxy, our home galaxy, projected across the sky. So going way back in time, the views of the night sky have played an important role in the development of human thought over the millennia. It is the canvas upon which the creation myths of many ancient civilizations were sketched. Our ancestors used the night sky for timekeeping purposes and for navigation at sea. It is perhaps most telling that of the 9 muses of Greek mythology, 8 represent inspirational goddesses for the arts, poetry, theater, song, etc. While the one remaining muse, named Urania, is the muse of astronomy. As such, astronomy is the only science singled out for this, in this special way by the Greeks. It is the lure and mystery of the night sky that first inspired me as a teenager to want to study the universe. To be clear, astronomy is much more than learning the constellations and the bright star names and looking through telescopes in your backyard, although that's how I started. It is a high-tech science, very high-tech science. It is driven by the design and construction of some of the most sophisticated scientific instruments ever created. For example, the Hubble and James Webb Space Telescopes. Has motivated the development of cameras and detectors that can record the light emissions from the universe in wavelength range from the gamma rays all the way through to the radio wavelengths. It has generated behemoth computer simulations that model the universe on all scales, from individual stars and gas clouds to large simulations of the evolving universe itself. The rapid advancement in our knowledge about the universe has been driven by these advances in technologies over the last 50 years. It has resulted in amazing images like the one shown, as well as much more complete and detailed understanding of how the universe itself works. Now, one of the draws of astronomy, regardless of whether you approach it as a scientist or just as an interested citizen of the universe, is the extreme natural beauty of what's out there. This image shows a large swath of sky near the center of the Milky Way and shows two bright regions of star formation. On the left is, left and lower part, pinkish part, is something called the Lagoon Nebula. And then the upper right corner is the Trifid Nebula. These are both in the constellation Sagittarius, the Archer. When people speak of communing with nature, we tend to think about walks in the forest or along the beach, maybe hiking up a mountain or going snorkeling on an offshore, near an offshore reef. All these experiences involve looking down. Looking down. But if you think about it, at any moment, here in the room, when you're outside, wherever you are, fully 50% of what you can see is above your head. Okay? Astronomers look up. And in doing so, we commune with a different part of nature, the universe we live in. To further underscore the importance of looking up, I only need to turn around and point out the heraldic banner of the College of Arts and Sciences, astronomy themed appropriately, with the stars on the side, but the three upward pointing arrows. They're just telling you, look up, look up. Okay. So whether we are looking at images or objects in the solar system, like this beautiful image of the planet Saturn, taken with the Hubble Space Telescope, which I just find stunning, or whether they're looking at star-forming regions and star clusters in our home galaxy, the Milky Way, or whether we're looking at distant galaxies. The universe provides a spectacular view. Never fails to disappoint. Now, I'm often asked what my favorite astronomical object is. This is it. It's called Leo P. Leo P is an ultra-small dwarf galaxy located about 5 million light years from the sun in the direction of the constellation Leo, hence its name. It was discovered via radio telescope observations at the Arecibo Radio Observatory that detected its cold hydrogen gas. Now, we subsequently identified it in the optical as one of the lowest massed galaxies known. This Hubble Space Telescope image shows the entire extent of the galaxy. It fills roughly half the field of view of this image. It's doesn't look very impressive, does it? And yet, this is one of the most fascinating galaxies out there, and it's been studied over the last 2 decades by numerous scientists. One could also see dozens of background galaxies located behind Leo P, far behind Leo P. One of the neat things about this galaxy is it was discovered by 2 IU alums, world-famous astronomers Riccardo Giovanelli and Martha Haynes, and then subsequently has been studied by current IU faculty members and our students. Although Leo P is not nearly as photogenic as the other objects I've shown you. It is both near and dear to my heart and serves as a nice segue to the rest of the second part of my presentation. So when I was asked to give this talk, I was told that I should try to provide some real-life examples of the type of work I do. And then I was told I had a total of 15 minutes to give my talk. This is a tough task. I study the whole universe. And it's really, really big. So I said, how can I do this in 15 minutes? And they said, okay, you can have 16 minutes. All right. So let me start by giving you a quick overview of the types of questions that we try to address in my field. And they're listed as bullets in the top part of the slide. The types of questions astronomers try to answer is, how did the universe come into being, and how has it evolved with time? How do galaxies form and evolve? How do stars form and evolve? How did the Earth and other planets form? And here I'm not just talking about planets in the solar system. I'm talking about planets, the thousands of planets that have been discovered in or around other stars in the Milky Way galaxy. So these 4 bullets can be succinctly summarized by the 5th. Astronomers tend to understand humankind's place in the universe. Now that's a kind of a philosophical rather than scientific way of putting it, but in a very real sense, that's what we're about. How do we fit in? But we have to understand the nature of the universe before we can answer that question. One of the fun things about being an astronomer is that it's naturally cross-disciplinary. So as an undergraduate, I majored in physics and math, not astronomy. My own research makes liberal use of chemistry. During my career, I've written tens of thousands of lines of computer code. If I were a planetary astronomer, I'd need to be an expert in geology. If I was trying to study or search for life in other worlds, I'd have to know a whole bunch of biology. So the practicing astronomer gets to apply knowledge of many disciplines every day. So that really makes it fun. We also get to study the universe in many different wavelengths, because the different objects in the universe will send us light in very different, often non-optical wavelengths. So we have to be adept at looking across the electromagnetic spectrum to really understand what's going on out there. Now I'll talk directly about my area of research. I study galaxies beyond the Milky Way, our home galaxy. In some cases, the galaxies I observe are billions of light years away. My specific interests focus on how star formation occurs in these galaxies and how the various chemical elements are built up over time in these galaxies. I'm also interested in galaxy demographics. So I want to know whether star formation and chemical evolution is the same in all galaxies or is different in different galaxies. My work touches upon the areas covered by the 3 bullets at the top of this list, but mainly focuses on the second. So since I had this insufferable short amount of time to talk, I only have time to talk briefly about one of the areas that I work in. So I've decided to focus on the chemical makeup of galaxies. Before I show you how I carry out this research, I want to start by letting you know a few important facts. Right? And these aren't necessarily important for the rest of the talk, but just to put everything in context. By everything, I mean our place in the universe. First, as this slide shows, when the universe was created in what cosmologists refer to as the Big Bang, it's kind of an awful name, but that's what they call it, the only elements that were created initially were hydrogen and helium, the 2 lightest and simplest of the elements. So the only atoms that existed were hydrogen and helium. None of the elements that we know and love here on the Earth were present in the early universe. There was no carbon or oxygen. There was no iron or silicon, just hydrogen and helium. So where did all the other atoms for these heavier elements come from? The simple answer is that they needed to be created after the Big Bang. And the only way that this can happen in nature is through the process of nuclear fusion inside of stars. In particular, massive stars can create many types of atoms through nuclear fusion in their cores, and then at the end of their lives, they explode as supernovae, tremendously energetic events, and generate additional chemical elements. These newly formed atoms are then blown back out into space, where they can coalesce into gas clouds and eventually form the next generation of stars. Okay, so important point one, the universe recycles. We wouldn't be here if it didn't. Okay. So the details of this process would take too long to explain, so you have to trust me. But the undeniable conclusion that one can infer from these basic facts is that every atom inside your body that's not hydrogen or helium, or in the chair you're sitting on, or in the air you breathe, was once inside a star. Think about that. Every atom in your body, every atom in the air you're breathing today, was once inside another star. Okay. As Carl Sagan famously said, we're all made of star stuff. The universe recycles, and without that happening, we wouldn't be here. So if you doubt that there is a strong connection between yourself and the cosmos, think again. So that was point one. Point two, the periodic table. Some of you are chemistry majors, I know, because one was sitting at my table. So you know all about the periodic table. You've probably memorized this, right? First of all, note the location of hydrogen and helium at the very top row, the two simplest and lightest of the elements, H and He. Okay. So if you're a chemist or a physicist or even a biologist, you know all about the periodic table. Astronomers take a different look or a different view of the periodic table, as you might guess. Because the universe started out as only hydrogen and helium, the distribution of the types of atoms we see in space is rather different from what we see here on the Earth. So here's the astronomer's periodic table. It's much simpler. Most of the elements are missing, in fact. Not that they're not there. But this periodic table is presented in such a way that the size of the symbols for each of the elements is proportional to the number of atoms present in the universe. Okay. Hydrogen and helium dominate. They make up 98% of all atoms by mass and 99.5% of all atoms by number. Completely dominate. As you could see, carbon, nitrogen, oxygen, and neon from the second row of the periodic table are present here. Magnesium, silicon, sulfur, and argon from the third row. So the next most abundant element in the universe after hydrogen and helium is oxygen. But in round numbers, there's only one oxygen atom for every 5,000 hydrogen atoms. Okay. And then all the other elements are even much less common. So, pick your favorite element: gold, silver, uranium. They're so small in number in proportion to hydrogen that they don't even show up on this plot. So in astronomy, all the elements that are not hydrogen and helium are called metals. Now it would take too long to explain that, but that's just our term, metals. Hydrogen, helium, metals. It makes things simple. All right. So clearly measuring the chemical abundances of astronomical sources is a challenge just simply because there aren't very many of those atoms out there. They're disproportionately underrepresented. Now you're probably asking yourself, how come we have so much of these elements here on the Earth if they're so rare in the universe? That's the subject of a different talk, and you probably do well to ask a geologist to come and give you that talk. Although I could answer the question, but I'll leave that go for now. Give you something to think about. Okay. So how do astronomers measure chemical abundances in other galaxies? How do I do it? Okay. So in short, we obtain spectra of the ionized gas in the vicinity of star-forming regions. This gas gives off strong emission lines, which are easy for us to measure even in very faint and distant objects. So on the left here, I show an image of the Orion Nebula. Anyone in the room who's a stargazer will recognize this one. This is the nearest large star-forming region to the sun in the Milky Way. So it's only 1,260 light years away. It's in the solar neighborhood, as we say. Okay. It is a large ball of glowing ionized gas that is excited by several hot stars in its core. One can see the Orion Nebula with the naked eye. If you go out to a dark site, find the constellation Orion, the hunter, the nebula itself is in the sword of the hunter hanging below his belt. Now, the image on the right is a very bright spiral galaxy called the Whirlpool Galaxy. This galaxy is 24 million light years away, So I draw your attention to the multiple red knots that lie along the spiral arms in the galaxy. Each knot is a distant version of the Orion Nebula, right? So look at the image on the left, that's our nearby example. Each of the little red dots in the Whirlpool is an Orion Nebula, essentially. Only they're 20,000 times further away. But with modern telescopes, we can obtain high-quality spectra of these knots and use the data to infer the chemical makeup of the galaxy, right? So I keep using the word spectra. Let me introduce you to one. Here's one such spectra. This is actually from an object I've studied. And when you take the spectrum of an object, you're basically spreading out or dispersing the light from that object into its constituent wavelengths. Okay, so the plot here shows the flux or energy, measured energy from the source on the vertical axis and the wavelength on the horizontal axis. So we've taken all the flux and we've spread it out by its constituent wavelengths. The old saying in the newspaper business is that a picture is worth 1,000 words. But in astronomy, I would claim that a spectrum is worth 1,000 pictures. While it's perhaps less appealing to look at the spectrum, it's not as visually exciting, the information content in the spectrum far exceeds that of the image. The way I like to put it, when you could take an image of an object in the universe, you're doing astronomy. And if you could take a spectrum of the object, you're doing astrophysics. So this spectrum is from the single star-forming knot in our friend Leo P, which is shown on the left here. Even though this is an extremely faint nebula, we are able to obtain a high-quality spectrum, and that spectrum exhibits emission lines from hydrogen, helium, oxygen, and neon, which are labeled. There's other elements there, but I didn't have room for the label, so kept it simple. Okay. This spectrum actually continues to longer wavelengths, that is to the redder colors, and includes other lines of hydrogen, helium, plus nitrogen, sulfur, and argon. So the very elements that were listed in the astronomers' periodic table are mostly all represented in these spectra. So even though this galaxy is 5 million light years away, we have obtained an accurate measurement of its oxygen abundance that has an uncertainty of only 2%. So we know the abundance of this thing to 1 part in 50. That may not seem impressive to you, but it's 5 million light years away. I'd like to see a chemist do something with 2% uncertainty at a distance of 5 million light years. So as the caption states, the chemical makeup of Leo P indicates a very low abundance of the heavier elements that is only at the 3% level of that found in the Milky Way. So my research group here at IU have obtained spectra of thousands of star-forming galaxies with a range of distances from the local universe, like Leo P, to distances of many billion light years. By way of a quick summary, this slide shows some of the key results from our research program here. We find that galaxies, exhibit a broad range of chemical abundances over a factor of roughly 100. The demographics show that the smaller galaxies have systematically lower proportions of the heavier elements than the larger, more massive galaxies like the Milky Way. So right away, this tells us that there's different physical processes going on in different galaxies that give rise to different abundances. This is important. It's one of the clues that help us understand how galaxies form and evolve. Overall, these kinds of results are used to inform and provide constraints for computer models that attempt to simulate how galaxies evolve. Now, before I press on, I would be remiss if I failed to mention that the research carried out in the astronomy department here at IU is made possible because we have access to world-class telescope facilities like those shown here and like Rick mentioned earlier. So Indiana University, and specifically the College of Arts and Sciences, makes annual financial contributions to support astronomy research by supporting ground-based telescopes like the WIN 3.5 meter telescope, which is the image on the far left here, and then the MMT 6.5 meter telescope on Mount Hopkins in Arizona. So myself and all of my colleagues in the astronomy department are grateful for this support. So as I come to the end of my talk, I'd like to circle back to my first thing. Whether you are drawn to astronomy by the beauty of the universe and then stay for the science, or vice versa, you will never tire of the natural beauty that you will experience. I am fortunate, very fortunate, to have been able to drink in the stunning beauty of the universe while at the same time probing its mysteries and studying its constituents. I hope that in this short discourse I've been able to convince you that spending time, even a small amount of time, looking skyward and taking in the vastness and glory of our shared universe is not a waste of time, but rather one great way to enhance the human condition. So I'll leave you by sharing with you a short excerpt from one of my favorite Robert Frost programs called The Star Splitter. Bradford and I had out the telescope. We pointed our thoughts the way we pointed it. And standing at our leisure till the day broke, said some of the best things we ever said. This simple thought really captures the essence of my message. Contemplating the grand nature of the universe inspires. Look up and get inspired by the endless beauty of the universe we live in. Thank you. Nope.
Thank you, John, for that amazing presentation. It's a truly memorable keynote. As president of Gamma of Indiana, it is my pleasure to induct Professor Sylvia Martinez as an honorary member of this distinguished society. This category of membership was created by the founders of the society at the College of William and Mary and represents a long tradition of recognizing faculty who embody Phi Beta Kappa's notion that the love of wisdom is the guide of life, and who by contributions in the fields of the humane sciences, letters, have given clear evidence of the possession of distinguished scholarly capabilities may be elected to honorary membership. Professor Sylvia Martinez received her PhD in sociology from the University of Chicago in 2006 and joined the IU faculty that same year. She is jointly appointed in the Department of Educational Leadership and Policy Studies and in the Latino Studies program in the College of Arts and Sciences. Her research focuses on Latinx education, Latinx ethnic identity development across the lifespan, and sociology of education issues more generally. She is currently working on a book titled Multiracial Latinx College Students, Navigating Sense of Place in Monoracial Contexts. She has served as the director of the Latino Studies program from 2015 to 2019, and most recently, the director of the Center for Research on Race, Ethnicity, and Society. And she is the newly appointed chair of the Department of Educational Leadership and Policy Studies. Professor Martinez, will you please join me at the podium? In accordance with the rules of the chapter and in consequence of the evaluation by the constitutional electors of Phi Beta Kappa of your many accomplishments throughout your career, the electors have acted to elect you member in course. You have been formally notified of your election, and by your presence here, you signify your desire to be enrolled as member of this ancient and honorable society. I am instructed to ask that you formally confirm acceptance of your election, and that when you become an elector of Phi Beta Kappa, you will have paramount regard for moral character and scholarly attainment. If you agree to this charge, you shall now respond, I do.
I do.
You have now affirmed your loyalty to Phi Beta Kappa and pledged to uphold its standards, and we welcome you into the ranks of membership. It is my pleasure to present you with the certificate of membership. Thank you. With the certificate of membership in Phi Beta Kappa. Congratulations. And now, if you would please sign the book for Phi Beta Kappa membership registry, which is a good rehearsal for our students. Congratulations.
Thank you.
Thank you. It is now my honor to recognize the winner of the Margaret Russell Edmondson Award, given each semester to a member of Phi Beta Kappa on the IUB campus who demonstrates the highest academic excellence. This award was established by the late Professor Emeritus Frank Edmondson in memory of his wife. Frank Edmondson was a distinguished scientist who throughout his career was a dedicated member of the Gamma chapter of Phi Beta Kappa, inducted at the conclusion of his junior year at IU in 1932. 4 years after earning his bachelor's degree in astronomy from IU in 1933, he was awarded a PhD from Harvard University. He immediately returned to the astronomy department at IU, where he became department chair in 1944, and remained in that role for 34 years. In 1972, he served as president of the Gamma chapter. At many of these induction banquets, he was accompanied by his wife, Margaret Russell Edmondson, herself a proud member of Phi Beta Kappa. Frank paid tribute to Margaret in many ways following her death in 1999, even naming an asteroid after her. But she might be most proud to know that this award for academic excellence has been established in her name. The recipient of this year's Margaret Russell Edmondson Award is Christopher Steinberg. Christopher, would you please come forward so that we can present you with your certificate for this special award? Christopher is pursuing a BA with a major in chemistry, and his post-graduation plans are to attend the Indiana University School of Medicine in Indianapolis. Congratulations, Christopher, on this most impressive achievement. And you'll get to sign the book afterwards when you're inducted. The chapter also selected one student for honorable mention, Gracie Whitaker. Gracie is pursuing a BS in biology and a minor in chemistry, and after graduation, she also plans to attend the Indiana University School of Medicine this fall. Gracie, will you please stand to be recognized? Please join me in congratulating Christopher and Gracie on their breadth and depth of knowledge in the liberal arts that Phi Beta Kappa extols and embodies. And now Terry Greenslade, Secretary-Treasurer of Gamma of Indiana, will conduct the initiation of our students, of our new student Phi Beta Kappa members.
It is my great pleasure to be here with you all this afternoon, and it is now my honor to lead our newly elected members through the induction. Will the inductees please rise? In accordance with the rules of the chapter and in consequence of the evaluation by the constitutional electors of Phi Beta Kappa of the academic performance throughout the period of your baccalaureate degree candidacy, the electors have acted to elect you members in course. You have been formally notified of your election, and by your presence here, you signify your desire to be enrolled as members of this ancient and honorable society. I'm instructed to ask that you formally confirm acceptance of your election, and that when you become an elector of Phi Beta Kappa, you will have paramount regard for moral character and scholarly attainment. If you agree to this charge, you shall now say, "I do." Very good. Always like to hear that I do. By reason of your election and your acceptance, the Society's requirements for induction are fully satisfied. Therefore, I declare you members of Gamma of Indiana, of Phi Beta Kappa, authorized to wear its key and participate in its meetings. Please be seated. We will now present the new members, Dean Van Kooten, Professor Velasquez, Professor Cohn, and Professor Oosterhout. Please join me on the stage. And I'll give you some instructions for how we will do this. First, Madam President, members of the Executive Committee, faculty members of Phi Beta Kappa, and guests, I have the honor of presenting these persons who have been inducted. Students, our chapter president, Professor Velasquez, will present you with your certificate of membership, while Dean Van Kooten, Professor Cohn, and Professor Oosterhout will welcome you into the society. We will display your names on these screens. When you see your name, please walk over to Michael, who will help you line up. So let's begin. Okay. Students, please come forward when you see your name. We will follow the order of the banquet program. While the first few students start to line up, let me explain the process on stage. When it's your turn, please come forward to accept your certificate from Professor Velasquez and receive congratulations from Dean Van Kooten, Professor Cohn, and Professor Oosterhout. Then sign the registration book and exit the stage to my right. I would ask the members of the audience to please hold your applause until all the electees have received their certificates. Let me add that we will read only the names of those members in attendance today. All right. Zara Greenfield. Zara is majoring in speech, language, and hearing sciences.
Congratulations. Well done.
Congratulations, Zara. Susanna Kukowska. Madison Taylor Rosenblatt. Madison is also studying speech, language, and hearing sciences.
Congratulations. Well done.
Congratulations. Alexis Scholta. Alexis is earning a BA with a major in history.
Congratulations. Well done.
Kylie Schreiberg. Kylie has a double major in gender studies and history.
Congratulations. Well done.
Congratulations, Kylie. Linnea Anderson. Linnea is earning dual degrees in neuroscience and Spanish.
Congratulations.
Ava Engel. Ava is pursuing a Bachelor of Science in Clinical Psychological Science. Isha Eris. Isha is earning dual degrees in psychology and a human biology Bachelor of Science. Autumn Barker. Autumn is earning a Bachelor of Arts in Journalism in the Media School. Shay Berry. Shay is pursuing a Bachelor of Science in Human Biology. Congratulations. Jacob Bracken. Jacob is earning a Bachelor of Arts with a major in Art History. Congratulations, Jacob. Kendall Brandenburg. Kennedy Bruns. Kennedy is earning a Bachelor of Science in Comprehensive Design in the Ashkenazi School of Art, Architecture, and Design. Samantha Burke. Samantha is a double major in criminal justice and psychology. Congratulations, Samantha. Ryan Sorali. Ryan is earning concurrent degrees of Bachelor of Science in Physics and a Mathematics BA. Autumn Chilinsky. Nev Chilla. Elizabeth Cho. Elizabeth is a double major with majors in International Studies in the Hamilton Luger School and East Asian Languages and Cultures. Congratulations, Elizabeth. Olivia Kutka. Olivia is double majoring in International Studies and French. Congratulations, Olivia. Fiona Dang. Fiona is a double major in fashion design and theater and drama. Congratulations, Fiona. Olivia Drew. Olivia is pursuing a Bachelor of Science in Psychology. Congratulations, Olivia. Jenna Everett. Jenna is pursuing a Bachelor of Science in Biology. Congratulations. Liliana Gonzalez Chavez. Liliana is pursuing a Bachelor of Science in Interior Design. Isabel Goodwin. Isabel is a double major. She's pursuing a Bachelor of Arts with majors in mathematics and psychology. Congratulations, Isabel. Mary Jane Hart. Mary Jane is earning a Bachelor of Arts in Journalism in the Media School and also pursuing a French BA. Congratulations, Mary Jane. Julie Heldman. Julie is pursuing a Bachelor of Science in Biochemistry. Congratulations, Julie. Eva Hernandez. Eva is pursuing a Bachelor of Arts in Chemistry. Congratulations, Eva. Natalie Hernandez. Natalie is pursuing a Bachelor of Science in Game Design, also in the Media School. Congratulations, Natalie. Hannah Height. Hannah is pursuing dual degrees, a Bachelor of Science in Clinical Psychological Science and a Bachelor of Science in Neuroscience. Congratulations, Hannah. Kate Hutner. Kate is earning a Bachelor of Arts in Journalism and a Bachelor of Arts in Fashion Design. Congratulations, Kate. Sanjana Jain. Sanjana is pursuing a Bachelor of Science in Neuroscience. Jocelyn Kerr. Sarah Knight. Sarah is earning a Bachelor of Science in Biology. Congratulations, Sarah. Myra Kotlik. Tara Kwok. Tara is pursuing a Bachelor of Science in Interior Design. Congratulations, Tara. Brooklyn Lambright. Brooklyn is pursuing dual degrees. She is earning a Bachelor of Arts in Journalism and a Bachelor of Arts in American Studies. Congratulations, Brooklyn. Lucas Lemmy. Lucas is pursuing dual degrees, Neuroscience, Bachelor of Science, and a BA with a major in Spanish. Congratulations, Lucas. Robert Mallard. Robert is earning a degree in astronomy, astrophysics, a Bachelor of Science. Congratulations, Robert. Meredith Madsen. Melissa Mendez. Melissa is earning a BA in political science. Congratulations, Melissa. Gideon Mervis. Gideon is pursuing a BA with a major in chemistry. Congratulations, Gideon. Zachary Mintz. Zachary is earning a degree with a major in economics and political science. Congratulations, Zachary. Catherine Mitchell. Catherine is pursuing a Bachelor of Arts in Psychology. Congratulations, Catherine. Meghana Mohan Kumar. Meghana is earning a Bachelor of Science in Biochemistry. Congratulations, Meghana. Laurel Morton. Laurel is double majoring in English and History, Bachelor of Arts. Congratulations, Laurel. Skylar Morrell. Skylar is pursuing a Bachelor of Arts with a major in media. Arshdeep Nagra. Arshdeep is pursuing concurrent degrees, a Bachelor of Science in Neuroscience and a BA in Chemistry. Congratulations, Arshdeep. Brianna Neary. Brianna is also pursuing concurrent degrees, a BS in microbiology and a Bachelor of Arts in Spanish. Congratulations, Brianna. Aika Noguchi. Aika is earning concurrent degrees. She has a Bachelor of Arts in East Asian Languages and Cultures and a Bachelor of Science in Biochemistry. Congratulations, Aika. Genevieve Oakley. Ashna Patel. William Charles Pebworth. William Charles is pursuing a Bachelor of Science in International Studies in the Hamilton Luger School. Congratulations. Autumn Pepper. Autumn is double majoring in International Studies and East Asian Languages and Cultures. Congratulations, Autumn. Addison Poulter. Addison is double majoring in political science and criminal justice. Congratulations, Addison. Nicholas Radford. Nicholas is pursuing a Bachelor of Science in Biology. Congratulations, Nicholas. Charles Ratterman. Charles is pursuing a Bachelor of Arts with a major in media in the media school. Congratulations, Charles. Jake Reasoner. Jake is pursuing a Bachelor of Science in Neuroscience. Congratulations, Jake. Catherine Reddig. Catherine is pursuing a Merchandising Bachelor of Science in the Eskenazi School of Art, Architecture, and Design. Congratulations, Catherine. Allison Rickert. Allison is pursuing a Bachelor of Science in Biology.
Congratulations, well done.
Congratulations, Allison. Abigail Ripley. Abigail is earning a Bachelor of Science in Molecular Life Sciences.
Congratulations, well done.
Congratulations, Abigail. Erin Schmeltz. Erin is double majoring in International Science and Spanish.
Congratulations, well done.
Congratulations, Erin. Cohen Schultz. Cohen is pursuing dual degrees, Bachelor of Science in Cybersecurity and Global Policy, as well as a Bachelor of Arts in East Asian Languages and Cultures. Congratulations, Cohen. Fatima Azra Sharafna. Fatima is pursuing a Bachelor of Arts in Criminal Justice. Congratulations, Fatima. Christopher Steinberg, whom you've already met. Christopher is pursuing a Bachelor of Arts in Chemistry. Congratulations, Christopher. Cooper Tinsley. Cooper is pursuing a Bachelor of Science in Biotechnology. Congratulations, Cooper. Caitlin Townsend. Caitlin is pursuing a Bachelor of Science in Clinical Psychological Science. Congratulations, Caitlin. Camila Trujillo. Karina Wang. Reese Watterson. Rachel Weber. Rachel is pursuing a Bachelor of Arts in Political Science. Congratulations, Rachel. Ella Weisberger. Ella is pursuing a Bachelor of Arts in Psychology. Congratulations, Ella. Burke Weldy. Burke is pursuing a Bachelor of Arts with a major in Biochemistry. Congratulations, Burke. Gabrielle Wheeler. Gabrielle is pursuing a Bachelor of Science in Biochemistry. Grace Whitaker. Grace is pursuing a Bachelor of Science in Biology. Congratulations, Grace. Natalie Wilson. Grace Zhu. Grace is earning dual degrees in human biology, a Bachelor of Science, as well as a Bachelor of Arts with a major in East Asian languages and cultures. If there are any new members whose names I have omitted, please step forward now so we can present you with your certificate. Okay, you've now met all of our new members of Phi Beta Kappa, Gamma of Indiana. Please join me in expressing our pleasure in their accomplishment.
Sonia, I think it's you.
As we come to the close of this event, we celebrate the new chapter you are beginning with your initiation into the society. Today, we celebrate the love of knowledge that has brought you here and the resilience, curiosity, and courage and determination that you will continue to bring to all your endeavors. Our world is complicated and full of marvels and challenges. And we need people like you, whose broad training in the liberal arts and sciences has helped to cultivate their creativity as thinkers. People whose analytical skills make them humane and resourceful problem solvers. People who want to put their learning to use in the service of others. Today marks the start of a new adventure for each of you. Election to Phi Beta Kappa makes you part of a wonderfully diverse community of thinkers across the nation and around the globe. A community of people who live meaningful, significant lives. Look around you. You are joining a cohort of energetic, driven, industrious people here and across the country who will join you in shaping this world. Save your program, because the members of your PBK class are your compatriots for life in the mission of this organization. Keep in touch. because our world needs all of you, working together, bringing all your energies and insights to bear in addressing the hurdles we face. The future is a lot brighter for having this team of scholars facing it together. Congratulations, PB Class of 2026.